Finally, we're ready to get started on the TinyML applications, kicking things off with keyword spotting. We've got a lot of good foundations that we have laid out so far, and we're going to start building applications on those strong foundations. One of the key things I want to get across to you as we kick off keyword spotting as an application is understanding that keyword spotting falls in the general realm of speech recognition. It is undoubtedly one of the most successful examples of TinyML. It has to operate with ultra low power efficiency. It has to run continuously. It has to be performed on device, all of which we'll be looking at in much greater detail. We'll learn about keyword spotting data sets. We'll learn about how to train the models, and we'll learn about how to deploy them and how to systematically evaluate and think about them. But before we go there, I want to help place keyword spotting in the general realm of speech recognition ecosystems. Typically, when you're dealing with machines that have full-on conversations with you, they're large ASR models, or automatic speech recognition models. They're large, they're power hungry, and keyword spotting is not one of those. It falls in the general realm of overall speech recognition, but it's a critical front end in order to wake up a more complex beast that is sitting behind the scenes. You want things that are at the front of the pipeline to be lean and mean and efficient, like keyword spotting. So what do I mean specifically? For instance, when you say, "Okay, Google," that's a set of keywords that wakes the machine up, where you can then perform full-on speech recognition. In this particular scenario, the aspect of "show me the calendar" is, a full-on speech recognition that's going on there, right? So where there is speech to text, converting the words that I'm saying to text, which are then used by the machine in order to figure something out. And it's able to come back to you with text to speech, where the machine speaks back to you. And now that's just in the context of "Okay, Google." Keyword spotting has a lot of applications. Just think about your household, right? Think about the numerous different devices that you have in your house. All sorts of appliances, doorbells, garage doors, TVs, maybe even your shower. Just look around your room right now and take for a moment and think about which one of these devices could actually use keyword spotting, where you give it a command and the machine actually wakes up and is able to do something. For example, if you have an oven, you might be able to say "bake at 350. All you need the machine to do is listen for the word "bake." And then it hears the word "bake," then you know it's the oven, and then you can give it a simple follow-on command. Now, keyword spotting does not necessarily mean that it's just one word. It could be a few words, but it's a subset of the general vocabulary, for instance. But the key thing is that you have to take any device that is right around you now, and you can think of ways to give it that capability and be able to respond to keywords, and that'll get it to do something, right? So now think about it in the context of cars. Most automotive companies today are looking at keyword spotting as a way to make the user experience much more smoother in the car. For example, you can say "roll down the window," or you might ask it to "parallel park for me." As you can see, they are very specific and small short sentences that I'm using. And the key thing that you want the machine to be able to do is spot those keywords in the general context of things that are going on in the speech paradigm. Another example could be when you're wearing smart glasses in the future, have augmented reality, for instance. You don't necessarily have to say "Okay, Google" in the middle of your conversation. Maybe you're having a normal conversation and you say something in passing, but the machine is listening for those critical words. And then as they happen, perhaps it projects an interesting piece of information onto your lens. And those are the kind of applications people are really excited about today when it comes to keyword spotting. That said, think about situations where you're not explicitly giving commands to the machine. In the example like we just covered now, like "Okay, Google," or when we say "Alexa," the key thing that we're doing is we are looking at the device and giving it a very specific command. But there are cases where the machine is constantly listening and is able to pick up keywords on the fly, say in streaming audio. A very good example here is "Now Playing" by Google, where your phone will be able to tell you what song is playing in the background if it happens to detect it. Well, now how does that work? You want your phone to use as little energy as possible, right? So you want it to be off most of the time. Otherwise, you're going to be charging it multiple times throughout the day. So now how is that we're able to do and build these phenomenal things and still have the battery last all day or sometimes even 2, while the machine is still able to sense and listen to things around us? Well, that's what you're going to find out in this series. We'll start off by understanding what are the fundamental challenges around keyword spotting. It's extremely important to have a deep appreciation for how to look at the problem space, because we can't just take the problem as it comes in. We have to change the input so that it's actually useful for the rest of the pipeline. Remember, one thing that I want to make sure is that I teach you is that the way we look at things from an end-to-end pipeline perspective, not just like, let me train my model. That's not useful enough. Once we understand the broader challenges of how to develop keyword spotting effectively, then we will move on to looking at the keyword spotting pipeline. Remember, I said that we will walk through all the way from data sets all the way to deploying the model. We will start by looking at what are the characteristics of the data that we need to have. We will actually be using speech data sets, which have become standard now effectively for keyword spotting today. Then we learn how to train a small model that will actually fit on the microcontroller. We'll also train models that we tried using before that don't fit on the microcontroller and figure out how to actually simplify the models and how to compress them into fitting on the microcontroller. We'll do the training in Google Colab, of course, and then in part 3, we'll learn how to deploy it. Then, of course, we've got to make this model small, right? So we'll have to understand how to optimize them. So I'm so glad that you learned about TensorFlow Lite and the whole thing about quantization and why it's so critical, because you're going to be using it repeatedly over here to shrink down your models. So hopefully you remember some of those fundamentals I taught you. Well, with that, get excited because we are going to have a lot of fun doing keyword spotting.